Assalamu alaikum students, this is Sir Abdul Samad Khan and today we are going to learn some other topics from the chapter of logarithms for grade 8 matriculation. So let's get started. Okay, laws of logarithms. There are actually 3 laws of logarithms which we are going to discuss today. The first law states that whenever we have asked to find out the log of any two values that are multiplying with each other, we have to find out the log of those values individually, okay? And the second thing, we have to put the addition sign between them due to this multiplication sign. This is the first law. The second law states that whenever we have given any two values that are dividing with each other and we have to find out the log of those values, so first of all the same thing we have to do, that we have to find out the log of the both the values individually, number one, and number two, we have to put the negative sign or the minus sign between them due to this division sign. This is the second law. And the third law states that whenever we have the value which has the power or the exponent, that power or exponent should be taken before the log, and we have to find the log of that value without any power. These are 3 rules which we are going to apply in the upcoming questions, okay? Now, change of base in logarithms. Here we have a question log to base b of m is equals to log to base a of m dot log to base b of a. So what we have to do, we have to take one value from it and we have to prove this statement. That how can we prove this statement? So first of all, if we observe in this question, we have 2 log with the same basis of b. One is on the right hand side and one is on the left hand side, okay? So and this one is log a now. So what we have to do, we have to take this value and we have to assume it as any variable like a, b, c, d or x. Usually in algebra or in mathematics, when the value is unknown, we usually suppose the value as x. So I am going to suppose that value as x also, number one. Number two, as we studied in the previous lecture, that this is the logarithmic form, and whenever we have asked to convert the log form into the exponential form, the structure is like base to the power is equals to that number or value, okay? So I am going to convert this value, the log form, into the exponential form. Now let us convert it in the exponential form, that is, it will become somehow like this. Q. Why? Because a is actually the base, okay, and x is actually the power, and m is actually that number which we will get if we apply the power x over a, okay? Now what we have to do, we have to apply logarithm on both sides with base b. Now applying log to the base b on both sides, we get what we get like this. We have already given a to the power of x on the left hand side and m on the right hand side. What we have done over here, we have just apply log to base b on both sides, okay? Now if we see here, we will find that the third property or the third law of logarithm is applicable on the left hand side. Why? Because we have a base and there is a power over it as well. So what was the third law of logarithm? Now applying third law of logarithm, and that states that the power should be shifted before the logarithm. The power in this case is x, okay? So it will become somehow like this. X will be shifted before the logarithm, and we have to find out the logarithm of only that value without any power, that is a, okay? And on the right hand side, we have log to the base b of m, okay? Now what we have to do, we have to just substitute the value of x from equation 1. In the previous slide, we have seen that we have supposed x as log, now substitute the value of x from equation number 1, and the value of x in equation 1 was log to base a of m. So what we have to do, we have to substitute the value over here, and all the values are remaining as it is, and this is the actual statement that we have asked to prove that. So it's proved, okay? Now how to calculate the antilog of any value. Antilog is actually the opposite of the log. In the previous lecture we have learned how to find out the log of any value. Basically to find out the log of any value is actually to find the power, okay, or the exponent. In this case we have to do the reverse thing, like log of which power or log of that power will give us which number. Log of base 10 to this power will give us which number. So we have to find out that particular number in this case, okay. So what we have to do, like first of all we have to know that the value which appears before the point is actually known as the characteristic, and the value which appears after the decimal point is actually known as the mantissa, okay. So now what we have to do, we have to find the values from the chart of anti-logarithm by the same procedure. The procedure is that the two values of this whole value, actually we have to write the starting two values combinedly or collectively, like 43 will become 43, and we have to search the value from the column of 7 and from the row of 43. This is the whole description, okay. At the intersection of the row led by 0.43 and the column headed by 7, we find the number 2735. This number 2735 is actually in the chart of the anti-logarithm table, okay. Now in continuation of the row and under the mean difference column headed by 6, we find the number 4. So we will get two numbers, 2735 and the second number is 4. So we have to add both the values and we will obtain 2739, which is actually the value, okay. Since the characteristic is 0, so x must have one digit in its integral part. Thus we get x is equals to antilog of 0.4376, and our final answer will be 2.739. That was the actual value, the two values which we got from the antilog table, 2735 and 4, and when we add those values we got the answer 2739, okay. So that's our answer for the anti-logarithm, okay. Find the value of x if x is equals to bar 5.1245. okay. In the previous lecture we have learned then that whenever the value starts from 0, the characteristic should always be taken negative, and that bar indicates that the characteristic is actually negative, okay. So -5 means we have to put 5 zeros between the value which we are going to check from the table of the anti-logarithm. The same procedure we will going to apply, that 0.12 it means 12. 0.12 means 12. We have to travel in the row of 12 and in the column of 4, and then in the column of 3 in the mean difference column we will get two values, okay. As in the above example we have to follow the same procedure. The only difference in this case is the characteristic is negative, that is 5, so we have to put 5 zeros before the value which is being obtained, that is like this, okay. So what we have to do, we have to find the value from the antilog table from these four values 1, 2, 4 and 3, and we just the value which we got is 1331, okay. And these 5 zeros are actually due to this negative characteristic, okay. So that's our final answer for this value, anti-logarithms. So that's all from today's video. Hopefully you all understand that video. Inshallah we'll meet you in the next lecture with some other topics. So till the next time, thank you so much for watching and Allah Hafiz.